just want you, so, Desmos, I like it because it will graph everything even if it's not solved for y. Your calculator can't graph it. So, like, if I have x plus 3 squared over 5 plus y minus 2 squared over 10 equals 1. So Desmos will graph anything for you. So this is an ellipse that we have here. So today, we're going to take this plus, and we're going to make it a minus. And it makes the graph look, makes the graph look completely different than what you started with. This is a hyperbola. These points right here, like let me just copy this. You can kind of see how they fit together. If I change this back to a plus right here. So you can kind of see how they fit together there, the differences. They share those same points right there. No, it wouldn't be exactly the same. No, this part is sort of mirrored, but then we have, for a hyperbola, we have what we call slant asymptotes here. So, like a hyperbola, it kind of looks like a little bit like a sideways parabola, but it's not, because as I zoom out, you'll see it really just looks like an X, right? Because what happens with a hyperbola is that it curves, but then it gets closer and closer and closer to a line there. So if you're zoomed way out, a hyperbola looks like an X. If you're zoomed in, you can see the two curves that, are sort of facing each other there. So let's look at our notes for today. We've got some terminology we have to know. We also are going to graph a few of these, but not in as much detail as we've done the other problems. So with a hyperbola, it can either open left and right, or it can open up and down, and we'll look at why they're different here in a second. So we have the center is not actually a point on the hyperbola at all. The center is the point halfway between the two curves. So the center is actually, like if we were looking at our Desmos graph, the center is right here at negative 3, 2. It's this point that is, in the middle, right there. It's not actually on the graph, or inside of the graph, really. The vertices are going to be either to the left and right of the center or up and down. We call the line of symmetry that goes down through the middle of in between the two curves, we call that the conjugate axis, the one that does not touch. The one that cuts across the two curves, we call that the transverse axis. I'm not going to ask you much about that. I just want to throw these words out here in case you see them on the exam. Maybe you will remember seeing them before. We also have these slant asymptotes. So these curves get closer and closer and closer to those lines. That's why when we zoom out, it looks like an X. And of course it can look a lot different if it opens up and down. All of these same things apply, but your transverse and conjugate axis would switch if you had that, because the conjugate axis does not touch the two curves. The transverse does touch the two curves. If you remember, whenever you were in math, I think it's math 2, you do like the transversals. You've got two lines with the line that goes across them, looks like this. And you're like talking about angles, like we know this angle right here and this angle are the same. So this line right here is a transversal. So it cuts across those lines. The transverse axis cuts across the curves here. So that hopefully might help you if you remember those. And hopefully they're not going to ask you that question, because I feel like that's a bad question. If all you take away from pre-cal is that that's called a transverse axis, then and that's not the main point of the class, but they might, because they do crazy things on that test. So, the way that we can tell whether or not it opens to the left and right or the right and left is based on whether or not the x or the y is negative. So if our x is positive, here, so we've got x minus h squared over a squared minus y minus k squared over b squared. So the minus comes before the y for this one. Then this is going to be a hyperbola that opens to the left and to the right. Okay, and then the stuff is listed there for you. The center works just like it does with a circle and just like it does with an ellipse. It's the opposite of whatever is inside of these parentheses. Do be careful with this because sometimes, like on the next one, sometimes the y's first. Whatever's with the y is your y coordinates. Whatever's with the x is your x coordinate. If the parabola opens, or not parabolas, hyperbola opens to the left and to the right, then your vertices, you're going to go to the left, the square root of a, or left, the square root of this number, and to the right, the square root of this number. Sort of like with an ellipse, we go left or right, that amount. The difference is we're not going to go up or down for this because we just need these two vertices right here. So, like here, whatever this a value is, we would add or subtract that to whatever our h value is. The transverse axis is the one that cuts across. That is a horizontal line, so it's y equals whatever the k value is, whatever that y coordinate is. Of course, the conjugate would be the opposite, would be the x equals the h. Okay. If the hyperbola opens up and down, then the y is going to be positive. So for that one, y is positive. So notice right here, like the k comes first, but it's still the y coordinate in your center. So sometimes kids get their center backwards if that y is first, because they make this the x coordinate and this the y. So pay attention to that. In this case, if you're going up or down from the center, you would change the y coordinate, and then the transverse axis here is x equals h. So there are a lot of other things about hyperbola that you could get into. We could figure out how to find those asymptotes, those slanted lines that it gets closer and closer and closer to. But because we don't have that much time, and I'm betting on them not asking you about it, we are not going to, like, I'm not going to make you graph those by hand or find those slant asymptotes. I don't think you'll see it. The whole test is calculator active whenever you take the exam. So if you had a hyperbola, you could probably sort of figure something out about, like, getting it to match, plugging in numbers, and checking things. So hopefully that will not be an issue. So let me show you what I am going to ask you to do. So we're going to have to put these in standard form. The good news is it's almost exactly the same as the ellipse. The only difference is the negative that you're going to have. So whenever we have an equation like this, we're going to have 9x squared minus 54x minus 4y squared minus 40y. And then I'm going to move that 55 over to the other side. So you're going to complete the square and solve this just like you would for an ellipse. The only difference is whenever you get here to this, you want to factor out a negative instead of just a positive number. So here we're going to have a 9 times x squared minus 6x plus blank. And here we want to factor out a negative 4. So we'll have minus 4 times y squared plus 10y. On whichever one has the negative, right? Because for it to be a hyperbola, only the x or the y will be negative. Right. Okay, so everything really is pretty much the same as the ellipse. So it's not really anything too new, even though it looks completely different than the ellipse, right? So you're going to complete that square. So what will I have in my binomial here? Minus 3 squared. What number do I put here? 9. What number do I add to the other side? 81. Good. And then I'll have minus 4. What number will I get here? We'll get 5. And we'll add the 25. What number do I add over here? Negative 100. Very good. Because you're multiplying it by that negative 4, so you have to add a negative 100 over here on the other side. And let's see, what's that give us whenever we do that? 36. Oh, this is a nice one because we get a nice even answer there. One of your x's or your x squared and your y squared will have different signs. So one will be positive and one will be negative. Otherwise, it looks exactly the same. But one x squared will be positive and one of the x squareds will be negative if it is in a hyperbola. All I would have to do to make this an ellipse is change that one sign right there to a plus, and that would change it to an ellipse. So if they're both, if your x squared and y squared have the same sign, it's an ellipse. If they're different, it is a hyperbola. I think it's kind of weird how just that tiny sign can make it so different. So you divide by your 36 here, just like we did with the ellipses. And we'll reduce, just divide by that 9, which happens to work really nicely here. Divide by the 4 here, so we get x minus 3 squared over 4 minus y plus 5 squared over 9 equals 1. Have any questions on that? Okay, so standard form is pretty much the same as the ellipse. If you were okay on that, then this should not be much different. Graphing, we're going to do sort of like a bare minimum graphing. We're not going to get a really precise graph. So what we're going to do is, of course, we need to know the center. What is the center of this? 3, negative 5. So my center is at 3, negative 5. Right there is the center. Remember, that's not actually on the hyperbola. Does this one open to the left and to the right, or up and down? Okay. It does not matter which number is bigger. It matters which one's positive or negative. So if x is positive, y is negative, because your minus right there is in front of that. So, and then you can go back to the original too to see which one was negative, the x squared or the y squared. And up here, like I could tell from right here that it was going to open left and right. So if the x is positive, it opens left and right. If the y is positive, really either one. So like right here, if this minus comes before the y, then the x is positive, the y is negative here. But it should be the same way in the original problem. So like here I've got a positive 9x squared and a negative 4y squared. So even right here, you can know that it opens left and right. Okay, so ours is going to open left and right because that x is positive. So this is what we're going to do. This is a very, very, very rough graph of this. Because this number 9 here does affect like how wide or how skinny or whatever the graph looks like. But we're going to ignore 9. We're just going to look at this. So this is 2. I need to go to the left 2 and to the right 2. And I'm going to draw me in some curves. The 2 comes from the square root of that 4 right there. Because I know it opens to the left and the right, that means I need to go to the left and right. So I'll take the square root of this number, and I'll just draw in those curves there. Yes, so it is symmetric. So whatever it looks like over here is what it should look like over here. Mine are not very symmetric in this picture, but they should be. We would take the square root of 9 and we go up 3 and down 3 if it were up and down. And that 9 does stuff. We could get much more complicated with the graph, but for what I'm going to ask you to do, this is going to be good enough. I think this gives us a good enough picture that we can kind of know what the graph looks like. Yes. Yeah. Okay. All right, any other questions? Okay, let's do this next one. Okay, this one will go up and down, and Gabriel knows that automatically because that y squared is positive and the x is negative here. So this one is going to open up and down. So it might even be a good idea to like write that down or jot it down so you remember it whenever you start graphing. So we only have a y squared, so we don't complete the square with our y squared. I would leave, you can write the y squared second if you want. I would leave it at the beginning, here, like this. And then you're going to have minus 5. Actually, let's just go ahead and do this because it's already in the right form for us. We're going to group those two together. What can we factor out? A 5. So we'll have, and let's take a negative 5. So negative 5, we'll get x squared minus 20. Oh, no, sorry, not minus 20. Minus what? 4x, and let's put a plus blank, and that equals 50. And this time we're only going to have one plus blank because we don't have to complete the square for that y squared. So this one is sort of like one where you only have to do sort of half the problem because the y squared is just alone. So whenever we do this, we'll have x minus what number? I think you're a step ahead. You're not in the same place I am. So we will have a 2 here and a 4 here and a negative 20 over here, right? So that equals 30. And here's another example of where you're going to divide by 30 and they don't switch, but they will at least reduce nicely here so you don't have to have an ugly fraction or decimal. So we get y squared over 30 minus x minus 2 squared over 6, because you're reducing here by dividing by 5. Oh, wait, not there. Dividing by 5 on top and bottom, and that will equal 1. Yes? Yes, you do. So you have a 10 here, and then you have like 100 here. Yeah. Okay, any questions so far? All right, so what's our center for this one? No. Positive 2, 0. Be really, really, really careful with that, because what Chloe said at first, 0, 2, is what most kids say, because you're used to the x being first here, but whatever is with the x is your x coordinate, whatever is with the y, which is nothing, so it's 0 here, is your y coordinate. So be really careful if it's the y that comes first there. So center is at 2, 0. This one opens up or down, so we would look underneath the y. We take the square root of 30, which is, we're going to have to estimate here, 5.47, so about 5.5. So we would go up about 5.5 and down about 5.5. And then I just need you to draw in your curves as long as it is a curved line and it's opening the right direction. That's good enough for me. We could get much more specific on trying to make that perfect, but we'll just go with this. Okay, questions? All right, let's see. Let me make sure that is in fact the homework that I want to give you. I think that it is. Let's see, 15 through 22. Yes. I want you to do these center, vertices, sketch a graph. The first 4 are already in standard form for you, so you don't have to solve them. You just have to sketch a graph pretty much. Find the center and vertices and sketch a graph. On the first 4, find center and vertices and sketch a graph for all of them. But the first 4 should be really quick because they're already in standard form for you. Okay.